So let's say we ask them to find the area of a 2 by not 8, but we'll do 18 sized rectangle. Now, hopefully you're already thinking along with me. I hope she doesn't make all the squares for a 2 by 18 rectangle. And you're right, I'm not going to, because that would be inefficient. In fact, it would probably get very messy. But at this point, we're hoping that our students have learned that we just need to multiply the width here by the length, 18. So we have 2 times 18 equals 36. And that's it. They know that that's not it, because hopefully we say units squared or square units. We'll say units squared. That's the area of a larger rectangle. The problem is here, for most of our students, 2 times 18 is not necessarily what should I say, like a math fact that they have learned to recognize quickly. Hopefully, eventually, I mean, it's just 2. You can hopefully double 18, but it's not something that they're really familiar with. So we want to give them a little help in being able to do more math in their head so that they're not out there trying to count squares, because counting squares is not efficient. So we want to give them kind of like legal cheats that they can get the answer more quickly and more easily with. So let's say we're going to make it into 2 rectangles, because the big rectangle is a little bit too big for us to understand. So let's say a student's having a hard time figuring out 2 times 18. So they say, well, let's think about this. I could very easily find the size of a 2 by 10 rectangle, right? So let's say this right here, this is our 2 by 10. And I think we could agree that fits into our original right here. Right there, it fits into our rectangle. Which would leave a smaller rectangle over here of what size? Well, if this is 2 by 10, then this one over here must be 2 by 8, because we've kind of connected our 2 rectangles. We've slid a 2 by 10 and a 2 by 8 together to make a 2 by 18. And students should be able to look at that and say, oh yeah, that makes sense. I could break it into pieces. In fact, that's an important part of learning area, is understanding you can break it into pieces and find pieces and connect them and find the whole area, basically. Okay, so this is easier now, because I can now say 2 times 10 equals 20. Well, that's awesome. That's not the whole thing, because I also need to find here, this is a 2 by 8, so 2 by 8 is 16. All right, so I know that the area of the left rectangle is 20 units squared, and I know that the area of the right rectangle is 16 units squared, or square units. And so 20 and 16 together, we can add it. 20 and 16 together, they should be able to figure out is 36 units squared. And what do you know? We have the same answer, which is always good. All right, we're still not at partial products, but we're getting there. Obviously, we're going more quickly than we would if we were teaching a student. That's why this video is for teachers and for parents, because I'm assuming you understand the math that we're doing. This is something that you would be building into their curriculum, building into the kind of times that you're tutoring them one-on-one, and bring this knowledge to its full fruition. This should all be going in, like they should all be processing this kind of information long before they actually have to use a partial products framework. Okay, so we just found a 2 by 8 area rectangle, or the area of a 2 by 8 rectangle, and we've also found the area of a 2 by 18. So now let's make it even more complicated and say, what is the area of a 12 by 18 rectangle? It should look familiar. Now this is definitely a, move my cursor there. This is definitely a math fact, 12 by 18. The kids may know 12 times 18, that's the area. Let's write it over here. Area is going to be 12 times 18, although they'll probably write it with an X, but it's easier for me here to do a dot. 12 times 18 should be the answer, but we don't know what 12 times 18 is, and We don't want to teach them to rely completely on their calculator. So let's say, all right, how are you going to figure this out? Well, we can use the same strategy that we used earlier to break this into smaller rectangles that we can understand, and then we're going to add up the total area. So let's say we put one rectangle here that's going to be 10 by 10. Because we know that if it's 12 by 18, well, we could put 10 by 10 right there. Well, what's that going to leave down here? If we have 12, we have 2 left over. So this rectangle here is going to be 2 by 10 if I kind of cut it off right there at the edge. Okay, now we have 10 here. Well, that means we have 8 left over right here. And let's break that into 2 pieces as well so that it's 8 by 10. Say 10 times 8. And this last one is 2 times 8. Well, this now should look very familiar to you. For the sake of not getting cluttered, I'm going to total this down here. 10 times 10 gives us an upper rectangle of 100. That's the area. 10 times 8, we're going to add on 80 units squared. Then we're going to add on the area of this lower part. 2 times 10 is 20. And then add on the last part, which is 2 times 8 is 16. And again, 10 and 80 is 180. 20 and 16 is 36. So if I add these together, I get an answer of 216 units squared. Now this is an area problem, but if you recall, and if you don't recall, you can rewind back to the beginning of this video, we have just completed exactly the same problem that we did as just a 12, let me write over here, 18 times 12 multiplication problem. We did it as a partial product, and it looked exactly like this area problem. So what is a partial products frame? Well, it's teaching students upper level multiplication using their prior knowledge about area. And that should be exactly how we teach them the structure. We still, in my opinion, some people might disagree with me, I would say we still want to teach them later to use the sort of traditional, looking back here, 2 times 8 is 16, 2 times 1 is 1, 2 times 1 is 2, plus 1 is 3, and then, so on and so forth to complete that problem. But we have a little bit more of a foundation to tell them why it works. We should always be talking not about multiplying 2 times 8 and 2 times 1, but we should be thinking about, how this is a 10 plus an 8, why this 0 comes in here. Oh, well, because we're actually multiplying 10 times 18, not 1 times 18. And those are topics for another video. But the idea is, yes, the traditional method is valuable for being efficient and having something we can do without drawing a big square every time we need to do multiplication. But we want to lay a foundation first for what multiplication looks like, where those numbers come from, and then we want to build the bridge to connect to the more traditional algorithm afterwards. Whether you're a teacher or whether you're a parent who's helping with work, it doesn't necessarily help to teach them the other algorithm because you don't like the new one, because then they still might make mistakes because they still don't know where those answers came from. So we will continue just after this to make a connection to compare, to go back to that original problem that we had and compare partial products and how we bridge to the next level of the traditional algorithm. Thanks so much.